everyone, welcome back to the course on Chemical Reaction Engineering 1. Myself Neeti Mehta, Assistant Professor at Chemical Engineering Department, LEC Institute of Engineering and Technology. So, let's just start our today's topic, right? Which is overview of chemical reaction engineering. Some portion or some important terminologies such as chemical kinetics, chemical process, thermodynamics, etc. we have already covered in our last session. Today we will start with the new topic of classification of reactions, right? In this particular session we will deal with what are various reactions, how we can classify those reactions. So now let's just start. Classification of reaction. Why we need to classify reaction? Because whenever we are dealing with reaction, we need to know all the properties associated with that reaction. Whether the reaction is endothermic or exothermic, that means whether it is going to liberate heat or it is going to absorb heat, right? Whether it is heterogeneous or homogeneous reaction or it is a reversible reaction, we need to know all these things. Just because once we know this, then and then only we can have a proper control over our process and our reaction, and we can then and then only convert our reactant into product in the best possible way, right? So let's just start our classification. So basically there are 6 types of classification categories which we have defined. So as you can see in these 3 pictures, we are having some kind of reactions here, right? So these reactions are basically subdivided into 6 important categories. First one is depending on the number of phases. That means the reaction is taking place in how many phases or how many phases are involved in the given reaction. Then there is a dependency on catalyst usage, right? Whether the reaction is taking place in presence of catalyst or in absence of catalyst. Then there comes molecularity of reaction. How many molecules of reactant are associated with the reaction? Then comes heat effect. What will be the effect of heat on the given reaction? That is, whether the reaction is going to liberate the heat or it is going to absorb the heat. That will be covered. Then comes based on order of reaction, what will be the order of given reaction, and last is on the direction of reaction, whether it is a reversible reaction or it is a reversible reaction, right? So one by one we will see all these 6 categories, and let's just start with the first one, which is depending upon number of phases. So as we know, there are basically 3 phases which are available: solid phase, gaseous phase and liquid phase. Depending on that, we have 2 categories, that is homogeneous reaction and heterogeneous reaction. So when we are talking about homogeneous reaction, the word homo means same, right? The word homogeneous is derived from the word homo, that means same. When the reaction is taking place between same phase, right? Same type of molecules, that is, if it is a liquid reaction, then both the reactants are liquid or are in the liquid phase, then those reactions are termed as homogeneous reaction. So for an example, carbon monoxide plus 1 mole of oxygen, when combines, they give you carbon dioxide. As you can see here, carbon monoxide is in gaseous phase, oxygen is in gaseous phase, and the formed product is also in the gaseous phase. So this is termed as homogeneous reaction. Then there comes a heterogeneous reaction. So in case of heterogeneous reaction, as the word itself suggests, that hetero means different. When more than one phase is involved in any kind of reaction, then it is termed as heterogeneous reaction. So this is the example of heterogeneous reaction. Cobalt oxide when combined with aluminium oxide, it will give this kind of product. So this is solid phase and how it works. Next comes is depending on usage of catalyst, right? Whether the given reaction which is taking place is utilizing the catalyst or not. So depending on the number of usage of catalyst, we can get two different categories. It can be a catalytic reaction or it can be a non-catalytic reaction, right? As you can see here, in this particular given reaction, nickel is used as a catalyst. So when we are using catalyst, then it is termed as catalytic reaction, and when there is no catalyst required for carrying out given reaction, then it is termed as non-catalytic reaction. Now, as you can see here that using the catalyst, the time of reaction can be reduced, right? The actual path of reaching from A to B to C to D is this one, and which is a longer path. But once you introduce catalyst, you can have a smaller path, or the time of reaction can be reduced. The next category is depending on the molecularity of reaction. So depending on how many moles are reacting, we can have three different categories: unimolecular reaction, bimolecular reaction, or trimolecular reaction, or it is also known as termolecular reaction, right? When single mole reacts and give you final desired product, as you can see here, when A is our given reactant, right? As you can see in this particular picture, A is the given reactant. When individual A reacts and give us the desired product, or when A gets converted and give us the final product P, then it is termed as unimolecular reaction. When two different moles combine with each other to give us the desired product, that is when A and B are reacting with each other to give us the final product, then it is termed as bimolecular. And when three different reactants combine together to give us the product, or three different moles of any substance combined to give us final product, then it is known as trimolecular or termolecular reaction. Next term is based on heat effect. So depending on the usage of heat, whether the given reaction is absorbing the heat or it is liberating the heat, we can have two different categories. One is endothermic reaction. As you can see here that the heat is absorbed here, endothermic, that means the heat is getting absorbed. And another category is exothermic, where heat is getting liberated. As you can see from arrows of this picture, the heat is getting liberated, right? So this is the example of endothermic reaction, where we need to add on the heat to complete this reaction. We need to supply heat for formation of product. And in case of exothermic reaction, as you can see in this picture, that these cookies require the desired amount of heat to get converted into final product, right? So the dough which is kept inside oven requires some proper amount of heat, then and then only they can be converted into cookies. So this is an example of endothermic reaction. Whereas exothermic reaction, as you can see, when we add this chemical in this liquid, the heat is getting liberated. So this is example of exothermic reaction. Next is based on order of reaction, right? Depending on the order of reaction, we have three different categories. First order reaction, second, which is having this kind of reaction, that is N2O5. When it is converted, it is getting NO2 plus half mole of O2. Then there will be a second order reaction and a third order reaction. So this is how the reactions are classified based on their orders. Next category is based on classification based on direction of reaction, right? So based on the direction, whether the reaction is reversible reaction or it is an irreversible reaction, we can have a different category. So if the reaction is reversible reaction, that is, as you can see in this given example, C2H5, C5H5OH plus C3COOH is getting converted into final product, but it is again getting dissociated into the reactant, right? So this is two-way reaction, which is known as reversible reaction. And the second category is irreversible reaction, where there is only forward reaction, no backward reaction taking place. So as you can see here, three different moles, that is A, B and C, are reacting with each other to form the final product. So this is how we can classify based on the direction of reaction. If the reaction is taking place in both the ways, that is in forward and backward, then it is termed as reversible reaction, and if it is only taking place in the forward side, then it is termed as irreversible reaction. So these are the 6 classifications which we have covered. First one is depending upon number of phases, that is homogeneous or heterogeneous. Then it comes to catalyst, so it will be either a catalytic reaction or non-catalytic reaction. Based on molecularity, it can be unimolecular, bimolecular and trimolecular. Then based on heat effect, it can be classified into endothermic and exothermic. Then on order of reaction, we can have first order reaction, second order reaction and third order reaction. And based on direction of reaction, we can go for reversible, irreversible reaction, right? So this is, hope all the topics which we have covered today is quite clear. Thank you.